All right, guys, here's the video that's going to explain how to do the problems that I want you guys to do for the day. So you notice problem number 8 here on the screen has 3 different tables. You're going to do 2 sets of these. So it says in each of the 3 functions, one will be linear and one will be exponential. One of the 3 will be a new category of function, so neither exponential nor linear. List the characteristics in each table that helped you to identify the linear and exponential function. So in other words, if you say it's linear or exponential, you need to say, here's what I saw in the table that led me to that decision. And then what are some characteristics of the new function? So say something about it. And then it says find an explicit and recursive equation for each. If you could do recursive, cool. We're not stressing that this year, but we just went over linear and exponential functions, so hopefully you can come up with the explicit equation. All right. With that being said, one of the things that you might struggle with is that these tables don't start with 0 as their x value. So I want to talk about how we can work backwards on both linear or exponential functions to get back to the 0 or even further if we want. So notice on the screen you'll see 2 beautiful tables. It's so hard to make straight lines with this pen. But one of them is linear and one of them is exponential. So hopefully you can look at them right now and you can just tell that the one on the left is linear. It's obviously adding by 2 every single time. So I'm going to just mark that, and we could tell right away that this is adding by 2. Excuse me. So if you can't tell the one on the right is multiplying by 2, maybe you thought it was adding by 8, you can check that 16 plus 8 is not 32, and so you should be good to go. If you're having a hard time knowing what you're multiplying by, but you know you're probably multiplying, you could divide backwards. So for example, divide 64 divided by 32, and you will get 2. Divide 32 divided by 16, and you will get 2. You could divide 16 divided by 8, and you will get 2. So if you're getting the same number every single time, you know that's what your common ratio is. You know that now whenever you're going down, you're multiplying by 2 every single time. So let's go ahead and put that multiplying by 2 every single time. All right, so we figured out which one was linear, which one was exponential. Now, how the heck do you get back to the 0? I didn't start, where it started in the problem. You can start anywhere. But the point is on the left-hand side, on this problem right here, I put a red arrow. If you're adding by 2 to go down, what's the opposite of adding 2? Subtracting 2. So to go backwards, all you have to do is subtract 2. So 6 minus 2 is 4. And 4 minus 2 is 2. Minus 2 is 0. Minus 2 is negative 2. So we can go back as far as we want if you just do the opposite. Instead of adding 2, you can subtract 2. Now coming over to the other side, we'll throw in some purple here. If you're multiplying by 2 whenever you go down, you divide by 2 to go up. So 8 times 2 was 16, but 8 divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. Divided by 2 is 1/2. 1 divided by 2. That's literally what a fraction is, by the way. 1/2 is 1 divided by 2. You would say that 1 divided by 2. So there's your answer. So we just worked backwards. You could probably put this in your notes, by the way, because this is a really good example of how to work backwards. So pause the video if you need to. All right, and then as you go down on these problems, you'll notice 9 also has 3 problems, but these ones have negatives and positives already. And so it kind of shows you a little bit different picture. And the reason I wanted you to go back to the 0 is because on question number 10 that I'm going to have you do, you're going to be required to graph these. And so you need to make your axes appropriate. You need to make your axes appropriate to the numbers that you're using. Don't make your axes go 1, 2, 3, 4, 5 if your number goes all the way to negative 17 or all the way up to 100. You need to try and make it appropriate. And with that being said, let me show you guys an example of what I mean. So there's two things that students do whenever they make graphs. That is horrible. Got to figure out how to use the ruler on this thing. Mr. Hernandez will show me. All right, there's two things students tend to do. You'll see a graph that goes all the way up to 100, but the values don't really match that. So let's say you have a table that says this. It says 0, 0, and then it says 1, 10, and then 2, 100, and then 3, 1,000, right? So they might go X is 1, X is 2, X is 3, no problem. But then they'll call this 10, they'll call this 100, and then they'll call this 1,000. Okay? This gap between 100 and 1,000 can't be the same gap as between 10 and 100 because that's way different. So this graph should actually be an arch or an arc of some sort, but if you graph this would turn out to be a straight line and it wouldn't look right. So with that being said, let me erase this shenanigans, just do some Control-Z shenanigans, and instead show you what you should do in this situation. If you had this situation, you would have to think about how to scale your graph in a way where you can fit 1,000. So you might have to count by hundreds. Okay, and I don't know if I can even fit it, but you might say 100, 200, 300, 400, etc. all the way. So 5, 6, 7, 8, 9, it'd be all the way up here. Okay, these are hundreds, by the way. Okay, so you'd have to scale it in such a way where you can fit all your numbers on there and the gaps look the same. So now between each line, they all are 100. And now if you were to graph this, 0, 0 would be here. 110 would be like way down here still. Okay. 2, 100 would be here. And then 3, 1,000 would be way up here. So now you can see your graph, whoop, even though I didn't connect the dots very good, they would have made an arc that went up really, really fast, but started off in this section kind of slow, but in this section got really steep. So that would look way different. So make sure you think about what numbers you choose for your axes before you just start drawing numbers. So you'll notice that we have some right here, for example, where we have a negative 17 or a 125th. So think about those numbers whenever you make your graphs. All right. Lastly, I want to talk about this go section. It's all about rates of change. Our rate of change, I'm pretty sure all of these are linear. So in this case, rate of change is talking about the slope. It's talking about the common difference. Okay, so make sure that you know what it's talking about with rate of change. Okay, on a graph, you find rate of change by slope, rise over run. Hopefully you can see my mouse, but I would find out how far, if I go over one x value, how far does my y value go up? Okay, so you would just go over one x value, which looks like it's actually right here. Wish I could draw on this. So go over one x value, and I went up. Well, this is super weird. Here's 1 and here's 2. My apologies. So over one x value, and then I went up 1, 2, 3, 4. So if y is 4 and x is 1, my rate of change is 4 because it's rise over run or y over x. So the answer is 4. I should have went down first. So 1, 2, 3, 4, and over 1. Now, you know this is positive because is going from left to right, it's sloped up. And the one next to it, number 12, would be negative. All right, number 13 should be pretty easy because that's in table form. Number 14 is a recursive equation. So just skip that one. Skip number 14. 15 is a graph. You should be able to do that one. And 16 is 2 points. So let me remind you really quick how to do 2 points. I'm going to give you the equation. You're going to be like, oh, I remember that. Okay, so y2 minus y1 over x2 minus x1. That's your slope. Okay, so let me just give you two random points, 6, 3, and negative 1, 4. Your x's are your x's, and your y's are your y's, and you can name them. Either one can be 1 or 2. So if this is 1, this has to be 1. If this is 2, this has to be 2. But they could have been, the 2's and 1's could have both been flipped. All right, we just plug in the numbers just to remind you. There's y2, there's y1, there's x2, and there's x1. 4 minus 3 is 1. Negative 1 minus 6 is negative 7. So negative 1/7 is my slope in this case. So now you should be able to do the problem on your paper. All right, then there's problem number 17, which is a word problem. So it's kind of similar to the ones we already did. So think about that one. 18, independent variable. Independent, just so you guys know, is your x, and your dependent variable is your y. So you should label your table like that, and that one should be pretty easy. Number 19, it's giving you 2 points. We already know it's arithmetic, so see if you can figure out what the rate of change is. If you're given 2 points, it's trying to say f of negative 4. That's trying to say that's your x value. So in your table, xy, it would be giving you whatever negative 4 equals. So if it says f of negative 4 equals 0, I don't even remember what it said, then that's saying this. That's saying negative 4, 0 is a point. If it says f of 6 equals 12 or some other random point, then you have this. So now you got to figure out what it's adding every single time and fill in these gaps to find your rate of change. All right, so hopefully that helps you guys. That's going to be an explanation to help out with all the problems. Make sure you see me. Either ask me in Zoom or come see me in office hours if you need more help. Later, guys.